The holes in the prongs of electrical plugs serve several important functions to ensure secure and safe electrical connection. Firstly, they create a spring-like action that helps the plug grip the electrical socket tightly. This tight fit prevents the plug from loosening, which could interrupt the electrical flow and potentially cause an electrical hazard. A loose connection can lead to arcing, overheating, and even fires. Secondly, the holes increase the surface area of the prongs. A larger surface area allows the electrical current to distribute more evenly. This is particularly important for high-power devices that draw a significant amount of electricity. By distributing the current, the risk of overheating is reduced, which can damage the plug, socket, or even the connected device. Thirdly, the holes aid in the alignment of the prongs with the corresponding holes in the electrical socket. This ensures that the plug is inserted correctly. Proper alignment makes it less likely that the plug will slip out of the socket, maintaining a stable electrical connection. Fourthly, the holes are designed to reduce arcing. Arcing is the formation of an electrical spark that can occur when a plug is inserted or removed from a socket. The holes facilitate a gradual transition of electrical current from the prongs to the socket. This gradual transition minimizes the likelihood of arcing, preventing damage to both the plug and the socket. Fifthly, the holes facilitate removal of the plug from the socket. They provide a convenient grip point for users. This allows you to remove the plug without having to touch the metal prongs. Touching the metal prongs can be dangerous, especially if the plug is still live or if there's a fault in the electrical system. Sixthly, compliance with safety standards. In many countries, electrical plugs are required to have holes in the prongs as part of their safety regulations. These regulations ensure that plugs meet minimum safety requirements and help to prevent electrical accidents. The specific requirements for plug design, including the presence and dimensions of the holes, are often outlined in national or international standards. The design of electrical plugs considers several factors, including the materials used, the dimensions of the prongs, and the presence of safety features like the holes. These design elements are crucial for ensuring the safe and reliable operation of electrical devices. The holes in electrical plugs are not just random features. They are intentionally designed to enhance safety and improve electrical connections. By understanding the reasons behind these holes, one can appreciate the engineering that goes into even the simplest electrical components. The geometry of the holes is also a factor. The shape and size of the holes are carefully chosen to provide the desired spring action, surface area, and alignment benefits, while also meeting safety requirements. For example, the diameter of the holes must be large enough to provide a good grip point, but small enough to prevent objects from being inserted into the socket. The location of the holes on the prongs is also critical. They are typically positioned near the tip of the prongs to maximize their effectiveness in gripping the socket and aiding in alignment. The materials used to make the prongs also play a role in the function of the holes. The prongs are typically made of a conductive metal such as brass or copper, which allows electricity to flow easily. The metal must also be strong enough to withstand the mechanical stresses of insertion and removal, as well as the heat generated by electrical current. The holes can also affect the mechanical properties of the prongs. The presence of the holes can weaken the prongs to some extent, so the design must ensure that the prongs are still strong enough to withstand normal use. This may involve using a thicker gauge of metal or reinforcing the prongs in other ways. The manufacturing process for electrical plugs also takes into account the presence of the holes. The holes are typically formed during the manufacturing process using specialized tools and techniques. The process must be precise to ensure that the holes are properly sized and positioned. Quality control measures are also in place to ensure that the plugs meet all applicable safety standards. These measures may include testing the plugs for their ability to withstand mechanical stress, electrical current, and other hazards. In addition to the holes, there are other safety features that may be incorporated into electrical plugs. For example, some plugs have insulated sleeves that cover the base of the prongs. These sleeves help to prevent accidental contact with live parts, reducing the risk of electric shock. Other plugs may have a fuse or circuit breaker built into them. These devices protect the connected device from overcurrents, which can damage the device or cause a fire. The design of electrical plugs is constantly evolving to meet new safety challenges and technological advancements. For example, there is ongoing research into new materials and manufacturing techniques that can improve the performance and safety of plugs. There is also a growing trend towards the use of smart plugs, which can be controlled remotely and provide additional safety features such as energy monitoring and surge protection. The holes in electrical plugs are a seemingly small detail, but they play a significant role in ensuring the safe and reliable operation of electrical devices. By understanding the reasons behind these holes, one can gain a deeper appreciation for the engineering that goes into even the most common electrical components. They represent a careful balance of functionality, safety, and manufacturability,